In this video, we're going to be finding the line integral. Now, this might turn into something quite long. Hopefully I can be quick and informative. But a line integral is generally going to look like this. You're going to have f so that might look pretty silly at the moment, because you're just like, what does that even mean? So I like to put things into a bit more of an applied manner, and I feel that the best way of learning vector calculus is to kind of do as much as possible, and then you get used to and you get to grips with how this all works. So firstly, we need to find f of RT. So now what we're going to do here is, you can see we've got 2ti plus t cubed j plus 3t squared k. So now what we're going to do is say that this is the x part, this is the y part, and this is the z part, and plug it into this equation. So now f would be 2, and what's the x? It's 2xy. So we're going to have 2t, and then the y part is t cubed. And then we have x squared, which is going to be 2t squared. And then we have 3z squared, which is 3t squared squared. Okay. So here we're going to have, if we simplify f of RT, we're going to have 2 times 2 is 4t to the power 4 I. That's going to be 4t squared j. And here, we're going to now be very careful, obviously, because obviously this is all squared within itself, and that isn't. So 3 squared, which is 9, times by 3, which is 27, and then t to the power 4. Okay, so now here we have FRT. And now we need to find dr by dt, which is simply going to be this right here differentiated. So that's going to be 2i plus 3t squared and did I put t cubed up here? Yeah, I did put t cubed. Alright, yeah, sorry. 3t squared j, and that's going to be 6tk. Right, so let me get another piece of paper, because as you can see, we have an equation here now of FRT and an equation here of dr dt. And our equation states we need to multiply them across using a dot. So all that means is you get the I terms and you multiply it to the I terms of this, plus the I terms of this multiplied to the I terms of this, plus the I terms of this multiplied to the I terms of this. So 4t to the power 4 times 2 is going to be 8t to the 4. Taking the j terms, we will have 12t to the 4. And then taking the final part, which is 27 times 6, which is going to be 162 t to the 5. Also, make sure your ij's and k's disappear, or whatever magic from that. Oh, you can make this a little bit easier for yourself, actually. There we go. So now it's a little bit more. That's pretty good. That looks good to me in terms of dt. And now we can integrate that. Integrate this. Sorry, that's a bit silly. I should have probably written that up here. Integrated. So that's now going to become 20 t over 6 plus 162 t over 6 6. And as you can see, we can simplify that as 10 over 3. 10 over 3 t to the 6. And then 162 divided by 6, which is 27 t to the 6. Sorry, that's wrong, isn't it? Yep, that was very silly. 5, and that's 5. Sorry, that is 20t to the power 4, which integrates into 20t to the 5 over 4, and then you get 5, 10, 15, 20, which is 4. So you're going to get 4t to the 6 to the 5 plus 27t to the 6. So that looks a bit better, other than the silly blodges that I've now made. And now we've obviously been told at the beginning that it's 1 and 0. So here, if we write 1 and 0 and plug that in, you're going to get 4, 1 to the 5 plus 27, 1 to the 6. All of this minus from 4, 0, 5 plus 27, 0, 6. So obviously this is 0, 0, and that's going to be 4 plus 27, which will equal 31. So there you have, we have found a little value for this line integral. And generally speaking, it's pretty much the same thing. You have a vector field. You get another vectors in terms of t. You're going to parameterize and replace all your x's and y's and z's with t's. Get it into f of rt, dr dt, and then you multiply them. You do a dot with each other, and you should get this. Obviously, don't make these silly mistakes with poor different integration skills there, and then you should get a nice little value.